Good evening and welcome again to my session about unit testing architecture and design using ArchUnit. I will start showing some slides, then we'll see some live coding, and at the end of the session, there will be some time left for your questions and for me to answer them, hopefully. So if you have any questions during the talk, please post them to the chat. I think I can monitor the chat on my second screen. Yeah, that works. So if you have questions, please post them, and I think I will answer them at the end of the talk. My name is Thomas Moch. I'm a software developer and a coach for agile engineering practices. But I did not invent or create ArchUnit. That was Peter Gaffert. He's the original author and maintainer of ArchUnit. And in the meantime, there are many, many contributors to ArchUnit. It's a growing project. It's used more and more in the community. And me, I'm just a happy user of that library in my and my customers' projects. So while I don't contribute to ArchUnit using code, I contribute by spreading the word. And that's why I want to talk about ArchUnit today. Let's start with a definition of architecture. What is architecture? And some clever people have many, many definitions of architecture. I've chosen a few. Some respected architects say it's all the decisions, all the technologies, everything that we consider important for our project, everything that's hard or expensive to change later on. Then there's the structure and conventions, package structure, naming, and so on. It could be the communication between the systems or the services, the inter-systems architecture. And there is the human aspect of architecture, and that is the shared understanding of the system and of its parts. And as today we're talking about ArchUnit, let's see what we can check, what we can test with ArchUnit. Of course, it's the structure and conventions. We want to check for packages, for dependencies. That's the easy thing that ArchUnit will, of course, provide. But it's also the decisions. We can code our decisions into ArchUnit rules that will be checked every time we run our unit tests. This is kind of an executable documentation. And this leads to the last but very important point. ArchUnit can document our shared understanding of architecture. What our team committed to do or not committed to do, we can code this as ArchUnit rules as part of our project. So this remains the shared understanding of our architecture of our project. What ArchUnit cannot test is the communication between two systems. So ArchUnit stops at the interface to another external system. We're going to check the internal structure up to that interface layer. Why would we test architecture? I mean, there's some architects. What are they doing all day long? Why should we as developers test our architecture? Let me explain my background, where I come from, in which projects I worked, and in which project I'm still working. There are microservices and self-contained systems. For example, in e-commerce applications, where we have our domains split into vertical slices, which we deploy as separate services, be it either single microservices, small microservices, or whole self-contained systems. But these systems are pretty small. We can check the architecture within these services, but there will be a lot of complexity between those services, and that we cannot check using ArchUnit. And the other part of my time, I'm working with those large code bases that we call the monoliths. And I think there are quite a few of them out there in the real world. The problem with monoliths is that all the classes belonging to one domain are scattered all across our large code base. And it's hard to find the classes that belong together, even if it's a really large code base. And the problem gets worse if you've got a layered architecture, which is pretty common in monoliths. Because if you are a large company and have a large monolith, it's pretty common that your teams are split like these layers. So you have a front-end team, a back-end team, and the front-end team has to have all the knowledge of all the domains that belong to the front-end. Same for the back-end team and the API team. So this is pretty difficult to manage, and I want ArchUnit to help me make this monolith more friendly by setting up rules that we can check and refactor our system step by step to put the classes that belong together in kind of modules. And if we make these monoliths even friendlier, we'll find similar structures. We'll create similar structures by refactoring. And maybe we'll still have layers in the core part of a monolith, but the some of our services, some of our modules are trimmed down, may have a different kind of architecture. And this way, we can split our monolith, trim down our monolith, cut some parts off, deploy them, develop them as separate services, and trim down our monolith to keep our complex system maintainable. The question is, once we split our monolith and we come to a system of services, should we still work with layers? And let's have a look how it would look like. I can structure my services, my microservices, with the layers, front and back end, and so on. I can do this. Then I have a user at the front and a back end, a database at the back end. But clever people found out that it's not so clever to speak of top and bottom, but of inside and outside. So we've got an architecture inside our services, and we've got external systems. And this leads us to a pretty common architecture in microservices that fits perfectly for domain-driven design. If you're building your systems with domain-driven design. And this is called hexagonal architecture or onion-style architecture or ports and adapters. And the idea is that we have small structured services that communicate with certain external systems, and we can structure our systems with an internal domain model, with application services, and with adapters for each external system. And I want ArchUnit to be able to check these architectural style as well. And ArchUnit supports this style of architecture. So we've got several architectures. We maybe want to migrate our monolith to, let's say, in ports and adapter architecture. How does it work? What can we test? What can we check using architecture? We can check for the dependencies between our modules, between the packages. This is for cohesion and coupling. This means, do the parts that belong together stay close together, the cohesion, and are they loosely coupled? And then we'll check for conventions and patterns like namings and structure and so on. A small word on our way to ArchUnit. Before we used ArchUnit, we obviously had some code checkers for metrics. Some of them you might know, like check style. And we used ClassCycle really heavily, and the brilliant JQ assistant. But some of them are outdated. Some of them are not customizable enough. That was a pretty large problem for us. And tools like the really brilliant JQ assistant offer a proprietary configuration language, and not all developers are familiar with this language or would want to learn this language. So we looked for something different. And at the end of 2017, I saw a tweet which said, here is ArchUnit, pretty early version. But I said, ArchUnit, that sounds like unit tests for architecture. Cool. Let's integrate this into my current project. And the next week, ArchUnit was up and running. What's really easy about ArchUnit is that it's plain Java code, or you can use Kotlin. It's plain Java code, and your architecture checks are just the normal plain unit tests. You don't have to learn anything fancy new. And you can customize ArchUnit, you can extend it using, you can write your own rules, you can write your own predicates, and that's pretty mighty solution, and it can be extended by all of us developers because we know how to write Java code, right? The checking is done at bytecode level, so that's pretty safe, but it doesn't catch everything like references in Javadoc. But most of the time, we explicitly don't want those checks on Javadoc, and the checking at bytecode level is just fine. Including ArchUnit is pretty simple. We just use the suitable artifact, and there are special extensions for JUnit 4 and 5, but you can use ArchUnit with any unit testing framework you like. Then you would include the ArchUnit dependency without any framework specialization. Well, yeah, and that's it. Then we can run and use ArchUnit. I think I mentioned this, yeah. We've got built-in support for JUnit 4 and 5, but TestNG is also possible, everything that you run your unit tests with. And there are some Maven and Gradle plugins that can enforce the checking of certain ArchUnit rules in each one of your projects. If you want to learn more about these plugins, which have been developed by separate companies, please have a look at the ArchUnit website. They're pretty easy to use, and you can distribute your basic checks to all your projects. Okay. I think let's do a live demo. Okay. Let's switch to presentation mode, and I think that's large enough. Okay. Let's have a look what I brought with me. And I'll publish the slides as well as everything that I code here on my GitHub account later on. I'll tweet a link to the slides and to the GitHub repo. So you can have a look what I've been coding here. And you'll find several examples here as well. We maybe have a look at them later on. Because I don't think I can cover everything during this live demo. ArchUnit offers a comprehensive user guide. It's easy to read, and I'll show you some of the features that you won't find that easily or that obviously in the user guide. We'll do some checks, and I brought with me a very simple application. Actually, it's just a package structure with just some non-functional classes, but we want to do some checks on the class names and on their dependencies. My demo project is like the vertical slices that we've seen at the beginning. I've got an order slice, a product slice, search, and user. And each of those slices is structured separately. We've got an API package with a model and maybe an order entity like a JPA entity. And I've got an interface for a service within that slice or module. Then we've got the backend. There's an order repository like a JPA repository. We've got an implementation of our interface, of our API. And in the front end, there's an order bean. Like a JSF bean or whatever front end you like. So let's write, and the other slices look the same. Let's write our very first ArchUnit test. Okay, let's create this Java class. No, let me have a look. Let me show you something else first before I write the very first test. Let's have a look at the POM, just for you to get an idea what I've included here. I'm running on Java 15, that's no requirement. ArchUnit requires Java 7 minimum, up to 15. That shouldn't be a problem. You don't need to run on the latest version. I just have it here for demo purposes because I like to demo on cutting edge and see if that works out. So I've included ArchUnit, the latest version. I'm using JUnit 4, can use JUnit 5, no problem. And I've included the Jakarta API that I can use some of the annotations. You can of course include Spring, Spring Boot, every framework that you like. You can even use it without any framework if you've got a homegrown framework. But the main point is I'm just using ArchUnit latest version on the test scope. Okay. Now, okay. Let's write our first test. Let's call this JCON. Yes. Okay, let's create a test method. A first ArchUnit test. And when we're using ArchUnit, we have to import all the packages and classes that we want to write rules about. So I need a class file importer. Let's see where it is. There it is. I need the class file importer, and now I can import packages. I do this by importing packages by name, but you can also include certain classes. You can import the class path with several options, and the user guide goes through all of these options. You can import jars, you can import locations, and you can write your own location providers. So it's really customizable. We'll just go with a simple version of strings, and I'll import just one package structure, com_moorsoft. Okay, that's, if we have a look here, that's everything in my demo. Now let's assign this to imported classes. Okay. No, sorry. Imported classes, okay. Now with these imported classes, I can use something like reflection, but it's only similar to reflection. ArchUnit imports its own meta model into memory, but I can do something like reflection. And let's say I want to get some information about this order bean. And this looks like reflection, but it's more powerful than reflection, but because beside all the expected methods like get package name, get simple name, get modifiers, I can get all the dependencies between classes, like get accesses from self. Which classes do I access? Which methods do I access? Get accesses to self. Which other classes do access my class? And this way I could write my own architectural rules using pretty raw old Java. This is what we're not going to do. But you get an idea of what's under the hood in the meta model of ArchUnit. And you get a lot more information than reflection. There are certain code units, everything you'll find in the class, like, for example, the static initializers and so on. You get information about everything that's in your class. But let's not do it this way. I want to write a rule for all of my classes, and I need some transformer that transforms the imported model into classes. And let's see, it's an ArchRule definition classes, and we'll have other transformers for methods and fields, and you can even write your own transformers for everything else you like. In one of my examples, there's a transformer for all the static initializer blocks in your code. So all the classes should be public. Yeah, that's a rule. That's a pretty simple rule, but it's a rule. And let's make this a static import. It's better readable. And then we'll assign this to our ArchRule. And I call this the rule. And you'll see this is a classes should conjunction, something about pretty implementation detailed. And I'll just call this the ArchRule, which is the superclass. Rule, not role. Okay, now we've got our first rule. Let's check this rule, or rather, let's check with a rule. Let's check our imported classes. And that's it. That's our first ArchUnit test, and let me run this. Okay, so we've got a violation. Classes should be public. Class BAM doesn't have the modifier public. What? Okay. So that's true. Let's make it public, and now I can run it. Yeah, the test is green, but it will not always be possible to change those modifiers, because maybe we're doing some reasoning, some checks about code that we cannot change. So maybe this class BAM has to stay package visible. What we're going to do then? Maybe it isn't a good idea to just force every class should be public, but let's say classes that reside in a package API should be public. That maybe makes more sense. And the two dots mean any package API somewhere on our package hierarchy. So I run this. And now BAM is still package visible, but since it's not in an API package, but in the demo package, the test is green because it doesn't fit to this rule, so everything's okay. So I think this already is pretty cool for you to get an idea how ArchUnit works. Let's write our second, maybe more realistic test. I'll just clone the test. Let me duplicate this. And maybe you've got a legacy application. Let's say an EJB application, and you want to modernize it. And we could say we don't want EJBs anymore. Let's move it to CDI. But let's do the first step. We don't want any stateful EJBs. I don't know if any one of you still does EJB, but there are EJB applications still out there. Let's say we want to prohibit stateful EJBs. So we say classes should not be annotated with stateful. Yeah, that would be pretty great. So let's run this, and let's keep our fingers crossed that we don't have any stateful EJBs. Yeah, okay. But don't trust any test that hasn't been read before. Let's make this test read, and let's say BAM will be a stateful BAM class. And now we got our architecture violation that says class BAM is annotated with stateful. And we've got this message from ArchUnit: rule classes should not be annotated with stateful was violated. Okay, we've talked about this a little bit, and you know why I don't want stateful EJBs. But the developers that come to our project in 5 years will not know why we set up this rule, and this might not be enough information. So we can add some reason why we have this this rule, and we can add this because they don't scale well. And now if I run this, I still get the violation. And when I look at the message, it says classes should not be annotated with stateful. That's from ArchUnit because they don't scale well. That's our reason. If this message from ArchUnit gets too big, we can just use as, and this way we provide all of the message. And now the message is they don't scale well. So we can replace all of the message but most of the time you want to use because to amend the message that ArchUnit generates. Okay. And I think you get an idea what you can do with ArchUnit, with annotations, with class names, with package containments. And that's really easy, and it's a Fluent API. Let yourself be guided by this API. It's easy to write those rules. So let's have a look how we check something more than just annotation and modifiers. Okay, let me copy this class. The numbering fits to my examples that I'll provide. So when you look at those examples afterwards, you can match them from the file names. So I will only need one of those tests. Now, what we're gonna check next. Let's say we want to make sure that we don't have impl class names, this implementation suffix. This is maybe pretty old style and we don't want this. So let's say we don't want our classes ending in impl. Let me look, classes, no, I want to write a different rule. Let's name it first, then we'll know how to write the test. Impl, let's call it impl in backend only. We want all of our implementing classes in the backend. Maybe we have some implementation, some impl classes in the front end, and we want to get rid of them. So we want to make sure all of our impl classes with names ending in impl, reside only in backend packages. And that's pretty much what I'm going to write in Java code. Classes that have a name ending with, I could use it, impl, should reside in a package backend. Yep, that's it. And this would be, I think, the perfect rule. I'll use a different one because I can do matching, and I'll use this matching method just to show you that it's possible. You can match in whatever form or kind you like on the class names. So classes that have a name matching ending in impl should reside in a package backend. Okay, seems reasonable. And there is the question of mocking. No, ArchUnit is not about mocking. It's not something like Mockito. You do reasoning about the existing classes, their structure, and their package structure. So this is no mock framework. We just write checks about the existing classes and their dependencies and their relationships and their containments and packages. No mocking. This is no mocking framework. So, and I just ran the test, and it says the class user impl in API model doesn't reside in a package backend. So there is, let's have a look at user impl. Yeah, where does it live? Yeah, it's in user API model, and it's impl, and it's not in backend. Okay. Now you see what I could do. I could say, okay. Let's make all these classes deprecated. Let's mark them deprecated because I might not be able to change the package. So I might not be able to do the refactoring to drag a user impl to a different package, but I could mark it as deprecated. And now let's change our rule to say either we move it to the correct layer or it's annotated with deprecated. Classes that have a name matching impl at the end should reside in a package backend or should be annotated with deprecated. Okay, now our test should be green because our class is annotated with deprecated. But there are circumstances when you cannot do that. That's the pity with architecture and with the legacy applications. So I might not be able to annotate it with deprecated. And if I run the test this way, it will fail again because it's an impl class in a non-backend package, and we cannot annotate it with deprecated. What to do instead? ArchUnit offers the possibility with certain configuration files, and this one is called ArchUnit ignore patterns, to ignore certain violation messages. And we can insert any regular expression, and I've provided an example regular expression, and I'll say every message that contains user impl will be ignored. Let's see if the test is green. Yeah, this way you can set up rules as a target for your refactorings, and there might be easy wins, and you can refactor those easy wins at once. And there will be classes that you cannot change right on. But then you'll have here in this file, you have a list of all the to-dos, of all the harder refactorings that you have to do later on, so you cannot forget about them. And that's pretty simple and helpful because you know all the places that you have to work on. But if you have a really large legacy application and you have thousands of places, thousands of violations, this might not be viable. This might not be maintainable. So what to do instead? And ArchUnit offers something else. First, let's see that the test is read again. Here it is. And now we can say, let's freeze our architecture. If you've got an existing architecture, we maybe want to say all the violations are okay for the time being. We take care of them later on, but we don't want any new violations for our rules. In this way, we can freeze our existing architecture and say everything that's there is okay, but please no new violations according to our rules. Let me copy this test again. Call it frozen legacy. Yeah, that's the same test. Yeah, we check that impl will be used in backend only. Now, this is our rule that we just ran. Let me run this test again. This is a little bit voodoo, but this works. This is okay. And now I won't do checks for this rule, but we're going to freeze this rule. How are we going to do this? Yeah, call freeze. And there's a freezing ArchRule, and I'll just freeze my rule. This way, all the violations will be frozen. You cannot add new violations, but you can get rid of the violations. So you can refactor them away, but you cannot add more violations for this rule. And this is done on a rule by rule basis. And this is pretty cool. You cannot, you don't need to freeze your whole architecture, but you can freeze all the single rules that you cannot refactor right on. Okay. Let's make a static import. This is our frozen rule. You see, this is a freezing ArchRule. This is a subclass, so I can just use an ArchRule here. And now I won't check the imported classes with a rule, but with a frozen rule. Now let's see what happens. ArchUnit tries to freeze that rule, but it says, we cannot create a violation store. Creating of the store is disabled. Please enable it by configuration. There is a properties file, ArchUnit properties. Let me open this. And I've added all the properties, so we can simply activate the store creation, and I'll activate the store update as well. Now let's see what happens. Our frozen test was red because there are violations, but now if I run it again, ArchUnit will be able to store the violations. So this test is green, and this might be unexpected, but you'll see ArchUnit has created some files. Let's see where they are. They're up here, and this is our ArchUnit store. And if you see the folder name, this is the default folder name for the ArchUnit store. You can direct it, you can point it to a completely different folder. You can even write your own storage providers that, for example, you can upload those created files to an AWS S3 bucket or whatever you like, SSH, FTP, whatever you like. Let's have a look into these files. In the stored rules, we have the violations, the messages of the violations. And in this rather cryptic files, there are the single violations that we just saw in user impl. And these violations will be ignored. This is why our test is green. Now let's fix this violation. So I go to user impl and make it deprecated for simplicity. I won't do a great refactoring here. I just make it conform to our rule. So we will have one violation less. And let me run our frozen test again. Now the test is still green because we don't have any more violations, but one less. And if we have a look at the stored rules, they are still there because we once had these violations, but the actual violation file, it's empty. And this is what IntelliJ is trying to tell me here, how to open an empty file. Yeah, let's open as text. And you'll see that the file is empty. Okay, so ArchUnit has ensured that we don't that we have only less violations, but no more. Let's try this. I'll break the rule again, and if I try this, I will get a violation again because the store was empty before, or this violation didn't exist. So we cannot add this violation again. And this way you can migrate your legacy application to new architectural rules step by step. And either using ArchUnit, using the ignore patterns or the frozen architecture, both concepts are powerful and you can use whatever you like. Okay, let me have a look at the time. Okay. Let me just show you some of the prepared examples. Some things that you should see. We can do some caching. The importing of the classes can be cached. The manual tells you everything about it. We can write rules about dependencies and inheritance. But let's have a look at architectures like layered architecture. Layered architecture is from the architectures class, and we can define our architecture with layer. We give it a name and define it by some packages. Here on the front end, we can define it by several packages. And this way we define front end, API, and backend. And then we can say where layer front end may not be accessed by any layer, and layer API may only be accessed by layers front end and backend, and so on. And then we can check this architecture. Okay, I think I'll show you some 5 minutes and then we go into Q&A. So we've got a violation because the backend user repository calls the constructor from the front end, and this is a violation. Okay. So it's pretty easy to define layered architectures, but what if you've got already a plant UML definition? Maybe you know plant UML, and we can have our architecture as plant UML, like front and backend API defined with stereotypes by packages. And ArchUnit can check those plant UML files as well. We can import these plant UML files. I've done this with a file name. You can use several possibilities like URLs. I load it as a simple file, and then I say classes should adhere to the plant UML diagram with several options. And if I run this, I will get the same violations. Believe me, they are the same. And if I now change my plant UML and say maybe, well, yeah, the backend may access the front end. Looks strange, but maybe. Then I will still get one violation, but not three, because two of the violations were backend is accessing the front end. But let's fix this pretty soon, because this wasn't layered architecture anymore. But if you're using plant UML and you have component diagrams with dependencies, you can just use it for ArchUnit to check your architecture. Okay. Now, two more things about architecture. We can have slices. Slices means we can slice our package structure with patterns. In this way, I slice my packages with this package hierarchy. This means I've got 4 slices of order, product, search, and user. And I can require they be free of cycles, which is absolutely valuable. We don't want cycles in our application. And you can also say they should not depend on each other, which is pretty difficult if you've got a monolith and the modules call each other. But if you've prepared them to split them up and they're already calling each other via REST or atom feeds or Kafka topics, you could say they shouldn't depend on each other in Java code. And then you can split them into microservices. Pretty mighty. And finally, we've got onion style architecture. And this is the ports and adapters or the hexagonal architecture. We can define this onion architecture with domain models at the inside of our services. Then we've got the application services around those domain. And we've got adapters for the external systems. And ArchUnit does the checking that dependencies only go from outside to inside and that the adapters don't access each other, that they're independent of each other. So that's pretty easy and powerful at the same time. There's a lot of more I could show you, like writing custom rules. Have a look at them. But I think I'll show you 1 or 2 more slides, and then we go to Q&A. Okay. So why should we use ArchUnit? If you've got a pipeline like this, you've got a built-in unit tests running and then maybe acceptance test and then goes to deployment. And many pipelines have architecture and code metrics like SonarQube or JQ Assistant running separately from the built-in unit test. And some architect is working on SonarQube or JQ Assistant and gives the development team some feedback. The problem is this feedback loop is pretty long because it takes some time for the architect or for us developers to have a look at SonarQube or JQ Assistant and to see the architectural violations. And once we see, when we see those violations, we already work on something else. We don't know what we did yesterday. So the feedback loop is too long and too late. And the benefit of ArchUnit is that it runs as part of our built-in unit test. It gives us developers immediately feedback. So the feedback loop is shortened a lot. And this makes architecture a team sport, not some occupation of a distant architect, but a team sport that the architect can support. Still, the architect can still support architecture by checking SonarQube and JQ Assistant and getting ideas of new architectural rules. And then we as a development team can write those architectural rules in ArchUnit and get the checks within our build step. And that's, I think, a pretty cool feedback loop, pretty short feedback loop. There are alternatives and complements to ArchUnit. You can combine them like JQ Assistant, Structure 101, SonarGraph, or Embold if you want to use some ML or AI to reason about your architecture and your fixes and possibilities. If you're into Spring Boot, there's an extension with monoliths that's based on ArchUnit. It's developed by Oliver Drothbohm. You'll find talks from Oliver on the web if you're interested in monolith, and you can have a look at his website. Everything else you'll find on the ArchUnit website. The official examples and my examples that I showed you here, and the ones that I didn't show you. There's even a .NET port. Yeah, now, do you have any questions? When did ArchUnit update the doc site? I don't know, but I think it's pretty cool at the moment. Yeah, it's pretty complete. Is it possible to define rules in a library on how a library should be used? For example, don't use classes from packages ending in private. Then are applied in the clients of the library. I don't know if it fits exactly, but I mentioned the Maven and Gradle plugins, and you can define your basic rules that you want to enforce in your projects. You can write your basic rules, store them in a jar file, and include them in a super POM, for example, and have the Maven or Gradle build script run those checks, so you can enforce some basic checks on all of your projects. You will, of course, write specialized tests in every project, but you can put general checks that you want to use in several projects into a jar file and use it with a Maven or Gradle plugin extensions. And please have a look at the website. It's explained there how to include, how to activate those plugins. It's not that difficult. Okay. What does it make better than SonarQube? I think, but please prove me wrong, I think that SonarQube cannot check all the dependencies, the callings of all the classes. It might be possible, but I'm not sure if it's entirely possible. But the main point for me is that SonarQube is running after our build step, after our unit tests are usually run, and then architecture is usually no thing of the development team anymore, but of someone in the team who's interested in architecture, and not of every single developer. And if I code my architectural rules in ArchUnit, they will break my build if I violate our architectural rules that we as a development team gave to ourselves. So it becomes a team sport in my experience, while tools like SonarQube and JQ Assistant run afterwards and are some tool of individual developers or architects. That's the main reason for me to use ArchUnit. And since it's usual unit tests, you get the results of the architectural violations reported in SonarQube as well. Are there limitations to ArchUnit? Yeah, of course, it's software. The biggest limitation is you can check within one service and not between the services. And if you go to microservice architectures, the complexity lies in the communication between the services. And that's one thing you cannot check with ArchUnit. You can check your, for example, ports and adapters architecture, that your adapters are written well, but you cannot check the inter-service communication. Yeah, that's probably the biggest limitation. Yeah, in a microservice architecture, we might replicate all the tests from one service to another service. And actually, I think that's a good idea for microservice architectures, because microservices should be independent and they should be developed by individual teams. And these teams might have other ideas about architecture. So if you put too much rules for microservices into basic checks, you might prohibit creative ideas from your teams. And doing microservice architectures, the basic idea is to get independent deployable services from independent teams. So we might not, some form of duplication is actually valuable in microservice architectures. But if you say you've got some basic checks, again, write your basic rules, your basic ArchUnit rules, put them in a jar file, and use the Maven or Gradle plugin for ArchUnit, which can then check those basic rules in all of your services. Would also be nice to have a check above the domain level, since we split up the layers in several projects. Please help me on that. I don't get it completely, I think. The checks, the classes that you reason about, that you write rules about, you define what classes to import. I imported Commuxsoft demo. I could also import a lot shorter path like Commuxsoft only, and then the reasoning about those imported packages. So it's possible on several levels to do the checks depending on which classes you import. Other domains that are not in the class path. You can do checks on jars in the class path. That is, if your application, your class path, already uses uses other services or other domain models or other domains, you can import those jars as well, and your ArchUnit will check the rules on those classes as well, on the classes or the jars on the class path. But actually, most projects that I've seen explicitly don't want this, so this is not the default. But when using the class file importer, the very first step in our ArchUnit tests, you can import not only certain packages, but everything that's on the class path or certain jar archives. And so this way you could do reasoning with your ArchUnit rules about the modules that you split your monolith into. Have a nice evening. Thanks for joining. Bye-bye.